Welcome to the Virtual Foundry podcast.
Hi, everyone. This is Brad Woods at the Virtual Foundry. I'm taking the lead in place of Tricia Cease, who is on vacation this week. So Austin and I are left to take care of ourselves in the podcast. This might be interesting. We'll see how it goes. This is podcast volume 4, episode 6. Today is June 20th, 2023. Currently in Midwest Wisconsin, Southwest Wisconsin, it's 82 degrees Fahrenheit, which is 24 degrees Celsius. And it's a pleasant sunny day here, though quite warm and getting warmer. Okay, Austin, what are we talking about today?
We are going to talk about kilns. Specifically, we can start with what kilns you can use with our products.
Okay, let's start with the absolute simplest. My original experiments with this process when I developed it in my basement, I developed it with a kiln that I paid $300 for. So incredibly inexpensive. And I should have a picture of it. They're like these little crazy igloo looking things, and you pick up the whole kiln. My point is that our material can be sintered in any kiln that can get to the correct temperature and hold that temperature for the correct amount of time. It is much, much easier if you have a programmable controller. You want to be able to program the kiln to increase its temperature at a certain rate over a certain time. So you want to be able to tell the kiln to ramp from 500 degrees to 600 degrees over a period of 60 minutes, for example. Most older kilns aren't like that. You just turn them on and they get hot. So we strongly encourage, in fact, if you write in and you're having a problem sintering our material, it's most common that we then find out that people are trying to get by without using a programmable kiln. So use a programmable kiln. Beyond that, the only factor that's important about this is people tend to overthink the kiln. And it's just a box that gets hot. And this is what we've come down to thinking of it as. It's the simplest way to look at it. The rest of it is unimportant. You're adding features. There are all kinds of different things you can add to the kiln. You can spend $100,000 on a kiln if you want, but you don't need to. We're about to release a new kiln in our store with a partnership with Scott. Scott is a very old company. They've been working with glass fusing, typically artists, and precious metal clays and general ceramics for decades. They're quite an old company. So our intent is to release a package that is the lowest cost option to metal 3D printing, lower than anything that's been out there to date. So we'll likely market this kiln for about $2,000. This will be the least expensive one that we've done so far. Let me share my screen here and show you a picture. So this is it. This is the Scott Firebox 8x6. So the internal chamber is 8 by 8 by 6 inches deep. It opens from the top and it has a programmable controller on it. These are the most rudimentary kiln controllers you can get. They call it a 3-key, but it'll do everything you want. You can create up to 6 or 7 segment programs. Our programs, as in the recipes that we publish on our website, only have 4. So this is more than adequate. This kiln will hit 2,250 Fahrenheit and hold that indefinitely. And the one that we have in the shop here has been a workhorse for us. We've cycled it hundreds and hundreds of times, and we're very happy with it. In fact, so happy with it that we decided to start reselling it. Ours will have an upgrade to the heating elements, so it won't be exactly the stock one that you would see on other websites, but it's very, very similar.
So what do you use a kiln for? Why would you use a kiln with our stuff?
Great question. Our filament are made of two things: a metal powder and a thermopolymer binder, very similar to PLA, polylactic acid. So it prints on regular printers. Any printer that will print PLA will print our materials. Once you've printed your part, two things need to happen. You need to remove the plastic from it, and you need to weld those metal particles together. So the job of the kiln is to slowly raise the heat in order to remove the debinder, or to debind the part and remove that thermopolymer. And then you run the kiln up to the sintering temperature of whatever metal you're working with. And generally, this is about 80% of the melting point. And that's part of what makes this process interesting, is you don't need to get to the point where you're dealing with molten metal. You're never heating metal to the melting point. You're only heating it to, like I said, about 80% of it. When complete, you have a fully metal part that's been densified, and it has all the properties of the metal that you're working with. If you've printed with, if you've 3D printed a part with our copper or a bronze or our stainless steel, the piece that you wind up with has the properties of that metal.
So a kiln is very useful if you need the properties of the metal. What if you don't need the properties of the metal? When do you not need to sinter?
Right. There's a couple applications where this comes up. The least frequent is people will just print and polish it because it looks like metal. So it's used for theatrical props, things like that. And it's also very dense. So it has the feeling of metal in your hand. The other is our tungsten material, which is used as a 3D printable non-toxic lead replacement, essentially. So it's used in shielding for X-ray. And tungsten sinters at a very, very high temperature. In fact, literally the highest temperature in the universe. And so sintering isn't necessarily practical. But what is practical is that it's incredibly dense. So dense that our unsintered, just like right off the print bed, our tungsten has the general radiation shielding properties of lead. And that's where that goes.
We talked about the firebox, and it's an 8 by 8 by 6 inch volume. And the kiln that we currently have on our website is 7.5 inches cubed. What's a good size for a kiln? Are those good sizes?
Yeah. The part that you're sintering and debinding needs to be held inside of a vessel that's filled with sand. Al2O3, we call it ballast. Some material will keep the part from sagging and deforming while you're removing the thermopolymer from the part, so during the debind phase. So yeah, the largest part that you can sinter isn't necessarily the size of the kiln, it's the size of the vessel that holds the part, the crucible. So what we recommend is you can comfortably do a part that's, I think we decided 60 millimeters.
60 millimeters cubed volume.
Right. So with the aluminum crucible on our website, you can debind and sinter very comfortably a 60 millimeter cube. And that will fit in that crucible. That crucible will fit into that kiln, the scut, for example. We have people that do larger parts and moving more and more in that direction. But as the parts get larger, the debind process becomes more and more complex. Maybe not complex, prone to failure, maybe is an easier way to say it. So it can be done, but as they get bigger, it becomes more challenging. And we strongly encourage people to start simple, start small. and start with the simplistic materials that we carry. We strongly encourage anyone that wants to start 3D printing metal parts using our process and our equipment. We recommend that they start with bronze. The advantage of bronze is that first off, it's one of the first materials that we've made. So we've been successfully sintering bronze and copper for over 7 years. So the process is very mature. The recipe is precise. If you follow the instructions, you'll get a good part. So our recommendation is to start there. Start simple, start small, and get a success under your belt before moving on to pieces that are more complex. And by more complex, we mean larger, thicker. The progression as far as difficulty goes is the copper alloys, and copper, of course. The stainless steel are the next they're slightly more difficult. They have a different recipe than copper and bronze and can be a little more challenging to master. The most complex materials to sinter are active metals. So active metals are materials that they don't appear in their natural state or in their pure state in nature. They're always tied up as an oxide, and these are titanium and aluminum. And these are two metals that they burn readily. They're highly reactive. When you heat them up, they want to bind with oxygen to the point where it will actually draw oxygen out of the fire breaks and things like that. So there are techniques for sintering titanium and aluminum, but they're a different thing. We recommend that people, like I said, start with the copper, work your way up to the stainless steels. Or I should also mention, we have glass and ceramic, and those are also very, very simple to sinter. They're not susceptible to oxidation the way that the metals are.
So the kilns that we were talking about are a good sized kiln. What if I have like 30 parts I want to center at once and I want to do them all at once? Can I get a massive kiln that's like the size of a room and center in that?
Absolutely. The size of the kiln is, I mean, it has no theoretical limitation. If you can get it hot enough and you can control the temperature, yes, they go up to very, very large parts in foundries and large, heat treatment houses and things like that. They all have equipment that will handle very, very large parts.
All right, so how can I get one? Not necessarily the big kilns, just a kiln in general.
Right. We recommend that you go to our website or one of our resellers' websites and look at what we're currently talking about the most. And in about a month, that's going to be the Scott Firebox. And that's on the very small end. Scott makes larger kilns also, and we'll work our way into those as we have more time to experiment and do a little bit of development with them. But for the people that want to start printing and you're comfortable with a part that's approximately 60 millimeters cubed, you can get started for, like I said, for very little money. And the other advantage of this whole strategy is that if you need to make more parts, you can just install multiple lines. You can install multiple kilns. At $2,000 a piece, the cost is negligible. And I say that in the context of other metal 3D printing solutions. And the next least costly solution that you can bring in-house is going to cost, $200,000 to $250,000 by the time you have it operational. And each sintering cycle is also very, very expensive. Our sintering cycles are very low cost. We don't consume shield gases. The consumables are minimal. And yeah, it just makes it makes it available to a greater number of people. Our typical user at this point is a student doing research, a research lab, the national lab systems, people working with alternative energy. We have a lot of green energy applications. We have people working on fuel cells. We have people working on methods of synthesizing ammonia, for example, using our technology, or using our technology to create the metal parts for the machines that do those things. So yeah, it's we used to kind of joke about it. We called it, or we still do, the democratization of metal 3D printing. So our intent here is to make this available to the greatest number of people possible. And what we're selling isn't a single solution. It isn't a push button answer to getting parts. It's a research platform. It's a method of getting to that point. And we're confident that the technology that we're working on right now in the future will be the solution that produces the push button parts systems. This part of additive manufacturing and 3D printing and powder metallurgy, metal injection molding, the binders and the debinders, this is pretty well settled as far as technology goes. This is how metal will be printed going forward in a way that's affordable and accessible.
So you touched on a little bit the scut being around $2,000. Our virtual foundry sintering kiln that we currently sell, I believe that's just under $3,000. That's probably a pretty good price range there, but you also mentioned the one that you started with was around 300, but that was also years ago. Although the pre-owned market probably hasn't changed too much because there is a point where the price starts to or continually falls.
Right.
So the barrier to entry is getting lower and lower.
Yes, it is.
And you can spend, like you said, tens of thousands of dollars if you want to, or if there's a feature that's available on those kilns that isn't available on the lower end that you need.
Right. And on the on the zero barrier to entry point is this can be done with propane. I do an example like there's a video on our YouTube channel called Forge Sintering, I think I called it. And that was just sintered with simple flame. I used a regular kiln to debind it. So I had to, before sintering the part, I ran it up to 800 degrees Fahrenheit to remove the binder. But then I just put it in a common propane forge that you can buy for $100 and sintered it that way. So people that are willing to be creative can get started on this for just a few $100s. It doesn't need to cost a lot of money.
And we've talked a lot around here about kilns that don't have programmable controllers and how you can take those out and replace it with an actual programmable controller. So if you have a kiln laying around that'll get up to the sintering temperature that you need and hold it for several hours. But it's not programmable. You can take that controller out and put in a different one that you can program.
Yeah, absolutely. We did the trophies for the 3dprintingindustry.com awards a couple years ago. I did all of those in an antique Duncan kiln made in the 1980s with a retrofit temperature controller, programmable temperature controller. And people with a little bit of engineering and willing to experiment, you can build your own programmable controller for $150 if that's what you want to do. But you can also buy the deluxe models for $500 or $600 that will integrate with your smartphone, so you can monitor remotely and all that kind of thing. At the end of our podcast, Tricia usually asks one last question, and it's a setup for a dad joke type of a situation. Austin and I discussed it and decided that we're not qualified to step into this area. So we're going to have to go dad jokeless for this version of our podcast.
So I think that's all we have for this episode. Did you have any final remarks?
Um, Final remarks on kilns are don't overthink it. It's just a box that gets hot. It isn't high tech, it isn't complex. Um, People think it's easy to look at this as a very complex undertaking, but it's just not. You just need something that gets hot at the rate that you want it to and is able to hold it over the amount of time that you wanted it to.
All right.
All right.
Thanks for joining us. Thanks for listening to us ramble.
Right. Next question.
All right.
Thanks, Austin.
I have been staring at this little bit of hair right here the whole time. I can't get it flat.
Right.